Good evening, everybody. My name is Monty Paulson. I lead the Passive House team at RDH Building Science, and I'm really happy to see you all. It's Wednesday. It's an honor to welcome you here to the Passive House Happy Hour, hosted by Passive House Accelerator. This is an inclusive gathering. We welcome people from all Passive House communities, as well as anyone else working to create zero emissions buildings with very little embodied carbon. So please turn on your cameras. We want to see you. Please turn on your microphones just for a minute here. We want to hear you, at least for the toast. And as fall begins in a pandemic, let us raise a glass and make a toast to operable windows in every room.
Amen.
Here, here.
Cheers, everyone.
Cheers.
Cheers.
Awesome. Now, mute your mics just for a minute. Close that other app you've got open, that game, because we have a great show, kind of a Lois Arena double hitter. First of all, we have a video of Lois and Deborah Morales at the slumber party at Cornell Tech Tower, and then a great presentation by Lois about passive, not houses. But first, let me introduce my co-host, Prudence Ferreira.
Hey everyone, thanks Monty, and thanks for joining us. I'm Prudence Ferreira, and I lead the Passive House practice for Morrison Hirschfield. For those of you new to our community, we're thrilled to have you with us. One of the things I really love about our community and Passive House in general is that we, as people, as practitioners, and the Passive House criteria are ever evolving. As Passive House practitioners in the field encounter new challenges and new building typologies and expand our knowledge, our certifying and standard setting bodies are also evolving, working hand in hand with us on pilot projects to help lay the groundwork for best practices that ultimately lead to new protocols so that everyone doesn't have to reinvent the wheel. As a CPHC trainer myself for a long time, I'm always so excited to meet the new cohorts. And as Passive House grows and we increase adoption, we're getting sharper and sharper minds asking really great questions about why Passive House approaches certain things the way they do and posing new ideas for how to streamline. By freely sharing information with each other, this happy hour is a great incubator for that evolution. So let's toast to that. Here's to evolution. So last week, we talked about having a pajama party at River Architect's office, and hey, we got one. We got a video where we're actually getting to join Lois Arena, Director of Passive House Services at Stephen Winters Associates, and Deborah Morales, who's a principal and Passive House designer at Handel Architects, who was the architect on that project. And for those of you who aren't familiar with it, it's the house at Cornell Tech. It's Passive House dorms on Roosevelt Island in New York City. And they're doing some firsthand investigating of how the building is operating and performing by becoming residents for one night. Now, during the video, these ladies mentioned a certain type of measurement device. Now, during the after hour, when we do t-shirt giveaways, whoever can answer first in the Zoom chat what that device is and what it does will get a t-shirt. Let's have a look.
Got our popcorn. It was expired popcorn, but it seemed to have popped quite nicely. And I was just actually in the hallway, and I did not smell popcorn.
Oh, that's very good.
Which is good.
Okay.
Right?
Yeah.
And
So we've
the popcorn is
completed a number of investigations this evening. It is 9:30.
a lot of interesting things.
A lot of very interesting things. We got here at 4, and we started by videotaping a little bit on the outside of the building, measuring the outside air temperature, and then we moved inside and we went to...
Wait a second.
Yes.
We tried to take a photograph on the outside of the building, but the automatic door just kept opening and hitting us. Too many openings of the automatic door.
It's not an automatic door. The guy at the desk,
Right.
what would you call him?
The concierge.
The concierge is pushing the button when anybody is coming or going. And he pushes it several times to leave it open longer depending on how close they are or not.
No problem.
And so both doors open at the exact same time, which lets a ton of air into that space. And they stay open for several seconds afterwards. So if you're doing an airlock entryway or a vestibule like that, you want to make sure one door opens first, much any other as the other ones, the first one's closing. One of the reasons Deborah and I came here today is to live in the space, to see is there anything we missed? Like, did we really miss how this building's behaving and if people are comfortable or not and why that would be and how it's actually operating? But we came up with some really good findings tonight.
And also we found there was a door open on the roof, which is
Twice today.
twice, which is fascinating because once that door is closed, we're down on the 3rd floor, we could tell the difference.
We could tell the difference.
Yeah, super impressive. What did we
Yeah.
use? A bolometer?
Bolometer.
A bolometer.
A low flow barometer.
I learned a new word.
This floor is actually out cantilever over the porch below and still consistently warm all through it.
Yeah, which is really encouraging because SWA drove us crazy. With, like, what the soffit was going to be, how it was going to be detailed. And we spent so much time, but it was worth it. It was worth it. Because I'm in my like socked feet on the floor and the floor is toasty. So yeah.
His asthma is actually better. He's from China and he realizes that the air quality in China is bad. But he said, when I moved to New York, my asthma got better. He goes, I didn't realize that you were filtering the air.
I know, that was really cool. It was
Yeah.
like, oh,
Yeah, I
you
know.
might change the life. We really have to talk to more people that live here to learn about how they're feeling and how their lifestyle is affected by it, so that we can share.
And how hot their apartments get when they're home.
Yeah.
Is this an issue? What else do we do? Is that?
We made pasta.
All right. That was fantastic. Thank you, Lois, and thank you, Deborah. So we are going to jump into breakout rooms. So this is a rapid fire introductions. We'll be doing this for about 3 minutes. So please introduce yourself and say a couple words. And I'll start the rooms now. See you in 3 minutes. I have created a weekly roundup, and this is on the Passive House Accelerator website. So there you see it's the top article. So if you're looking for links, you can just go to passivehouseaccelerator.com and find the links there. And you can see the announcement of tonight, of course, and you guys are all here. We have a great episode 2 of the podcast, low energy building plus straw bale panels. And you should check that out. John was a really interesting interviewee. The International Passive House Open Days is happening November 6th and the 8th, and they're doing that virtually. So there are a number of ways to get involved, and there's a link there that, where you can find out more. But if you want to do a video project tour, you could do that. You could submit that to them. FIAS has a number of different trainings coming up, CPHC training, FIAS plus Radar training, FIAS plus Verifier online training. All of that is happening the beginning of September and through November. And you can go to their events page for more information on that. And I mentioned last week this cool combination of the Level Up course with the Passive House. So you can do the Passive House Fundamentals course with PHI. For €95, you get 6 months of access to the 20-hour course. And that €95 also applies as credit for registration to the 24th International Passive House Conference, which will be held virtually September 20th through October 8th. Details there. As always, we like to share the online Passive House and building science gatherings that are going on. So NAPHN has its lunchtime special with Ken. That's tomorrow, and you can get information there about when and how to connect with that. Fine Home Building BS and Beer Show is about high performance house tour from 1700s to net zero, and that's tomorrow as well. We've got the Dave Cooper and Mark Wiley show, the BS Fridays, so you can get the link there. And on Wednesday mornings every week, Passive House Canada does a building conversations with Chris Ballard, and he'll be interviewing a Passive House homeowner next Wednesday. And finally, and I'll say more about this, we've got a cool Passive House happy hour lined up for next week. So again, you can get all this information on Passive House Accelerator. And with that, I'm going to hand it off.
Thank you, Zach. You know, it continues to amaze me. It was just a decade ago, it was really hard to find one Passive House course. There was no formal training in North America. And now you can learn more for free or low fee online in a week of sitting home on your sofa than you ever could. So I hope everybody takes advantage of it, some of that. Hey, so we all come to Passive House via different routes. Some of us came through architecture. Some of us came through engineering or energy modeling. Some came for policy, looking for ways to reduce greenhouse gas emissions or improve indoor air quality. And you know, in the breakout rooms, you've probably met people with other paths that are just as interesting. But I'm gonna let you in on a little secret. Some of the very best Passive House people, the people who are really making the world a better place, are failed builders. People who tried and really wanted to build things, but it didn't quite work out. And on that note, I'm honored to introduce Lois Arena, who was a general contractor for 10 years before joining Stephen Winter Associates. You probably know her as the Passive House consultant for North America's seminal large Passive House, the Cornell Passive House on Roosevelt Island. You saw that video earlier. You may know her as the Passive House consultant for Winthrop Tower Office project in Boston. You may know her for any of the other 7 million square feet of projects currently in design or under construction that Stephen Winter is advising to, consulting to. That's about 40 active projects and 60 buildings. 2 things you might not know about Lois though. 1, she loves horror movies, but she tends to watch them, you know, kind of peering through her hands, covering up, hiding from the fear and the terror. Here's the other one. Lois recently became a PHI building certifier, and as she and his term are learning, as those of us who've been certified in buildings for a little while know, certifying buildings is sort of the same emotional experience. It's a little terrifying to watch it all come together sometimes. So I'm absolutely honored to introduce one of the world's top Passive House consultants and a woman I count as a dear friend, Lois Arena.
Thank you, Monty. Hi, everybody. Thank you. And I just wanted to say, after you saw that video of Deborah and I'm never going to wear anything less than that to conferences when we start going back. So I'm going to talk about things that are passive and not houses today. And you guys, I mean, I know a lot of you on the phone, so I'm not going to spend a lot of time introducing our firm, but we're a consulting firm. We do all certifications of all kinds, consulting, sustainability, energy efficiency, and accessibility, and all types of buildings, as you'll see. So I wanted to sort of lay out the objectives for you today. And I want you to understand, and I know you know this, but some of you are new. So Passive House applies to any building type. You can apply the methodology to anything, and I'm going to show you that. I want you to be able to identify how you move forward with a challenging typology. As Monty said, you know, from a certifier's perspective, and Prudence said, we're all trying to come up with standard guidelines for these things. That's, you know, as certifiers in the United States and Canada and North America, we are trying to work with the certifying bodies to come up with ways for everybody to move forward in this challenging building type. So it's not just a one-off on every project that keeps our costs high and frustrating everybody. So I'm gonna go through schools, office space, laboratories, and an industrial building. And I just want you to pull one challenge from each of those building types and understand that even though there's these challenges, you can still go forward. And then I want you to walk away saying, and then somebody comes up to you and saying, you know, so-and-so, can I do my office building or my laboratory to Passive House? I want you to just say yes and move forward and know that we're out here, we've done these things, and we can at least begin to help you. So primary schools. The deal with primary schools is, and it depends on whether you're in an urban environment or a rural environment, how different the program can be in some of these schools. In urban environments, the schools don't really close for the summer for 3 solid months, right? They have summer program all year long. Some of them run on the weekends all year long. So their loads are very, very high. They need air conditioning for the entire school. I did not have air conditioning in my school. They serve the community in ways, especially low-income communities. They're almost like kitchens for the low-income families. They serve 3 hot meals a day in some cases, not just a lunch. And then, you know, there's issues with mechanical placement, like what sort of ventilation can you do? Do you have to go off the roof? Can you go to lot line issues? So there's very different things that urban and rural schools have to deal with. But one of the things you're going to see is most of them have these kitchens. Okay. Now the study we did was for New York Construction Authority. Charge was led by our very own Passive House warrior, Jeremy Shannon, and who headed this study. And what we were looking for was for New York City schools, they have to meet all city buildings in New York are required to reduce their energy use, new and existing. And so there's 3 targets that the city gave them. They gave them what's called the Local Law 84 target, and that is based on energy or utility data collected for years now on all of our different building types. And so that's one target. You have to do 50% lower than the standard energy use for your building type. Or you can do a percent better than ASHRAE, and I'm sorry, I think it's a 30 to 50%. I'll have to check and confirm that. Or you could go to the Passive House goal of 38, right? So these were the 3 targets lifted. And you can see ASHRAE is actually sometimes lower than Passive House. That percentage is hard to meet sometimes. But what I really want you to take away here is that this is the kitchen, right? 22 almost out of 88. So 1/4 of the energy use in that building is coming from that one commercial kitchen. And so you're going to see these commercial kitchens in hotels. You're going to see them in sometimes office spaces, right? They have cafeterias. You're going to see them in dormitories. So this is a common thing that we have to deal with. And we need a very simple way of addressing this and moving forward when we're doing our Passive House feasibilities for these types of projects. It can't be something that you're like, nope, it just puts us over the threshold right away and there's no way we can certify it. It's not true. There's plenty of projects that are going forward for certification that have commercial kitchens, and I just want you to keep that in the back of your head. And so some of the considerations you can use if you want to go to Passive House levels, it's really what we're looking for is using the best commercially available technology that you have available to you in your location, right? So can we go to electric cooking equipment? Well, there's actually some really good reasons to do that. As our grids get greener, our electric source factors are going to come down, our carbon factors. So there's a sort of a push to those all green grids that is going to push us to more electric equipment. There's also gas moratoriums throughout New York. And so, you know, there's certain neighborhoods where they're saying you cannot put gas in, you have to go all electric. So this sort of nips it in the bud, right? You don't have to worry about that at this point. You can also look at maybe not hot lunch every meal, right? Can you get a cold lunch in there? And I love telling people this, but it's so interesting when we evaluate commercial kitchens is that the food that is the worst to prepare, your fried foods and your you know, pizzas and things like that, use the most energy, those pieces of equipment. So it's like almost this beautiful synergy that the more healthy you can feed your occupants or your clients, the lower the energy use will be, which is, you know, this sort of seems like a no-brainer, but it's not. Then you can also, you know, find some synergies. There's so much refrigeration in a commercial kitchen. You can use some of that waste heat to heat some domestic hot water. And then, you know, there's hot water use reduction. There's a lot of cleaning and sanitation that goes into play, and there's alternate technologies to do that. So, you know, I just want, again, I'm going to reiterate throughout this whole presentation, there's ways forward, even though that traditional threshold that you see is perhaps not within reach. Now, office space. We have Winthrop Square, which is in Boston. It is a 55 mixed-use tower. And what we decided to do, this was a response to an RFP from the city that our team won, was to bring the office space, which is this 21-story section of the building right here in the center, to Passive House. And this is a Passive House pilot project. Because of that, as most of you are probably aware, Passive House doesn't like you to take a center section out of a building, right? They would love you to do the whole building. Sometimes it's too challenging, too costly. You know, this is an enormous building. This is millions of square feet. And the owner keeps getting asked, well, why didn't you just do the whole thing? And they're like, good God, can we just choose one section? So the center, for our first project, it's our first Passive House project. So the center is the office space. It's almost 1 million square feet. It increased since we started. The top is residential and the bottom is retail. And so this is a pilot project, as I mentioned, because this is not normal. And the reason we chose the office, if you look here, Boston also has utility data analysis for different building typologies that they've been collecting for years. And office was one of the highest energy uses per square foot for that typology was one of the highest. So we're like, let's make a case study of this and let's show the city what's possible, right? And so the current threshold that we're looking at for office space is about 50 kBTU per square foot per year. It's not 38. And we've been working with the Passive House Institute directly on this for a couple of years now. It's the people per square foot is very dense, so you're not going to get down to that 30 kBTU per square foot. Lots of appliances and computers and things like that. And this actually lines up, this 50 actually comes into line with what we see for some net zero office spaces. So that's really nice. Now, one of the difficult things about office space when you have this kind of density is that you have really, really high internal heat gains. And we're going to talk about internal heat gains for a few of these projects. So what Passive House generally would like you to do is use their standard assumptions, right, as PHI. But in the standard, it does say that if you have reason to use a calculated internal gain, then you can do that. And we felt there was so much internal gain and so many people per square foot that it only made sense to do it, because we wanted to fine tune the envelope, because it's cooling dominated the space. And if you make the envelope too intense, you're not going to just naturally lose some of that extra heat that you have to cool down. So the balance is actually on the cooling side. So we felt we had some very good. So we evaluated a couple different levels. We based it on what we thought the full occupancy would be based on the lease. The lease allows 120 square foot per person, or one person per 120 square foot. And then we said, well, offices are rarely at 100% capacity, so let's reduce to about 75% capacity. That would make more sense. Please assume that whatever's happening right now with this virus is not happening, because that's when all of this analysis was done. And so here's what your PHPP kind of looks like if you use the standard assumption for PHI and the heating demand, right? This is based on a really good curtain wall, sort of pushing the edge of technology out there for curtain wall. And then if we use our 25% occupancy, 75% occupied, then we come into compliance, right? So we definitely want to make sure that we're fine tuning these and we're doing what's best for that property, that typology. This is an old PHPP. I'm sorry, I was lazy and I didn't update it so that you could see the new numbers, but it is more around 48, 49 kBTU per square foot per year as far as the whole, the PE is right now. So let's jump into laboratory. So laboratory has very interesting. Now, commercial space, office space can have high ventilation rates, but it's nothing compared to what you're going to find in a laboratory. They have code requirements. And so you'd be looking at air change rates from your ventilation from 6 to 10 air changes per hour, right? Way, way higher than the Passive House standard would require. But it's a requirement, it's a code requirement. So we have to build, it's a health requirement. We have to build to this. So how do we actually dimension the envelope when we're talking about 10 air changes per hour? Or 6 air changes per hour. On the other hand, we also have an internal gains problem with these projects where we have a ton of lighting, equipment, stoves, lots going on. This is actually a science high school. It's a laboratory high school. And so what happens is when your ventilation rates are high, your heating demand goes up, your cooling demand goes down. But when your internal gains are high, your heating goes down and your cooling demand goes up. So you've got this really fight that, so like, where's the sweet spot? How do I dimension this envelope? And I was playing with the PHPP today. And what's really interesting is if you take your ventilation rate, which is what our standard approach is, and we've talked to PHI about this, and they've done this on other projects that have really high ventilation rates, is you bring the ventilation rate to a standard Passive House acceptable level, right? 0.4 to 0.6, somewhere in there. 0.4, I think is what we're using. Then you look at your envelope. You fine tune your envelope and you look at your cooling demand, right? Then what you do is you bring it to the real internal gains levels and the real ventilation so that they balance themselves out. And you kind of wind up with this really interesting balance point in your building. That sort of works. It works a little bit on the heating demand and not quite on the cooling demand, but we're just in the beginning of the feasibility. But again, these are methods going forward that, if somebody came to you and said they have this very high-tech, sciencey laboratory type building that they want to use, there's going to be a method for you. And we're part of the certifier circle with RDH and Andrew Peel and PHA and all the other certifier circle that we're all trying to work together and work with PHI directly to come up with some basic guidelines. It's going to be slow, right? Because we don't have a ton of these projects in the pipeline, but know that we're out there trying to come up with this guidance for you. So here's what the lab floor looks like, and it's a very mixed use space, right? We've got in blue, we've got laboratory where the actual students will be working and conducting their tests. And in the center, you've got this host of support spaces that ranges from everything from like a cold room that needs to be refrigerated to just dry storage to sterilization, which is going to take a lot of hot water. So you've got this real contradiction in spaces inside, and then you've got meeting space, right? So different mechanicals, different loads, different everything. So very complex, interesting project. All right. Now we're going to go into our final building type. I think I might be running a little close to over, so I don't want to take your time so much. So industrial. This is a project that was finished. It's done, and it's operating beautifully. And this is in Sri Lanka. This is climate zone 1, hot and humid. And this again was a pilot project because we'd never done anything like this, and I don't think PHI had done anything until this one either, especially in this climate zone. So this is a factory. It's a sewing manufacturing plant, and so not manufacturing. It's a industrial facility. So they make clothing samples here. And so they had all of this sewing equipment in the factory, and they were going to take that out. It's a gut rehab project, but that exact equipment was going to go back in. And so we had to come up with the scheduling for this equipment. This is another thing that's difficult on these odd projects. How long does that equipment run? You don't know. And when we first started doing our analysis, we had utility bills to compare to, and we had the equipment running for a very long period of the day because they're like 12 hours a day, Monday through Friday, and then 8 hours on Saturday, I think. So just a ton. And we were way over on our utility bill predictions. So what we did was we had them take us to, when we came in for a preliminary visit to interim to see how the installation was going, we had them take us to a nearby facility that was also a sewing facility. And we just watched people. We videotaped them. We watched them use equipment. And it turns out that the equipment's on for only a few seconds every minute because they have to push the material through the sewing machine, take it out, the machine stops, then they have to do something with that material, either fold it or do something else to it, and then they put it back in. So when we finally adjusted our run times, we came right into where their utility bill matched up with what our predictions were. So that was really good to see. So you're going to probably need to do some investigation into a similar type building if you have some odd processes that you need to evaluate. So here's the finished product. They did a beautiful job with this. It's light and beautiful. Everybody on the campus of the manufacturing plant wants to work in this facility. You can see all the machines were brought back in. And the architect, Jordan Parnas was the passive house consultant of record from the United States. He worked with a local Sri Lankan architect who did most of the design. Jordan was in charge of, we were in charge of helping with the wall assemblies and to PHPP modeling and all of that stuff. And then you can't really see it, but on this back wall is their commitment to their workers and sustainability. So, very beautifully done, very well thought out. And so here's the final. When I tell you you can make passive house work for any project, you can. The gray line at 80,000 kilowatt hours is their existing building data. The blue line was our passive house prediction, and the orange line is the new actual total utility bills for a year. So we actually came in slightly under the passive house predictions, but pretty close. And, they're very, very happy. And that's more than a 50% energy savings over what their existing utility use was. So Monty had asked me to put together a slide that shows you what the comparison of calculated versus standard assumptions are from PHI so that you can see how high they actually are and why they affect heating and cooling so much. So for the school, the first number is the school's calculated internal gains. And you can see if you chose the standard assumptions from PHI, you would only have a 0.089. So you're at half. And the kitchen is a 6.61. So, super, super high. And the number in parentheses is watts per meter squared for all of those rest of the world who is not IP. Sorry, guys. Office space came in at 1.54 based on our occupancy and equipment assumptions. And then the standard assumption was 1.1. So you can see why that changes the envelope efficiencies. Laboratory, super high, 3.71 standard assumption. The standard assumption is because it's a high school, it's a laboratory science high school. So we chose high school as the building type. There's no type you can choose that says laboratory. So, anyway, so you would do your own calculation for this anyway, but this is just to give you some perspective on standard internal gains versus what calculated is. And then for the Sri Lankan project, it was over 4. And so really, really affects how you design your ventilation rates, what you're gonna suggest for, can you do nighttime cooling and all of that stuff. So that's that. That is our crazy voyage into our bizarre projects that we've never done before for Passive House. And I really just want you to just understand you can do it. There's a way forward, and we're out here to help you. So please reach out for help if you come up with a crazy project that you want to do. And then the last thing I wanted to plug was we have a really great podcast on our website if anybody's interested. There's 2 or 3 seasons of talks on there, and it's called Buildings and Beyond. But if you just go to Stephen Winter website, you can find our podcast. It's right on the top right corner. So that's my spiel.
Thank you.
You're welcome.
Do you think you could do it again a little faster?
There was 30 slides, man.
And I celebrate that fire hose style. That's right there.
I know we've got a lot of questions, and I'm sure Sean has them queued up. I just want to kind of repeat one of the points you made that is so important is that, you know, I think the Passive House certifying organizations are really working to figure out what the right standards are for these places that have different internal heat gains that tend to be built in different parts of cities. Some of them might have different local heat island effects and other things happening. And so when we ask ourselves, you know, can it be a passive house? Should it be a passive house? We have to realize that a lot of the assumptions that are kind of baked into our thinking around residential buildings just have to go out the window right away. And I think your presentation really shows that really well. And I know, as you do through the Certifier Circle and through our conversation with PHI, they're actually really hungry for these projects. They really crave people coming to them with new types of buildings, new types of situations. So far from it being something they're resistant through, it's something they extremely want to partner as they have with you so effectively and work out those kind of things. What do we got for questions, Sean?
Well, first off, it's a tough crowd. You got a thumbs up and a thumbs down from the old white hair up in the rafters. So tough
The
crowd.
thumbs down guy, he has a hearing problem. That's why
Yeah.
I get a thumbs.
Totally. And
Does look a little like Stephen Winter.
Boom, chuck. All right, and question period begins. Jeremiah, you get to kick things off if you remember. If not, I can try to find it for you. And we've got a bunch in the hopper here. So Jeremiah, then Mike, then Susan, then Alana. Jeremiah, do you recall? It's actually a pretty simple one. Jeremiah, you there? He wanted to know if your data would be shared. Of course, the info will be shared on the Passive Accelerator, but if you want it faster, contact Lois and she can get it over to you.
Absolutely.
Mike, you're next.
Hey, thanks. That was great. I enjoyed it quite a bit. I had 2 questions. The first is, which is your favorite Passive House project you've done thus far, and why? And the second one is, if as you start to look at the projects that you're on right now, what are the solutions that we're really trying to work on or need to work on in order to be successful on the scale that we want to be successful? What are you seeing out there that like, yeah, we really need to solve this thing or those things?
This thing. So my favorite, I have to say, has to be Cornell. It was what I cut my teeth on large buildings on. It was beautifully executed by Monadnock and Handel, and you know, Borough Havel was the engineer. It was just really well done. It's operating wonderfully. It's not, you know, 38 kBTU, but you know, it's one of the better performing Passive House projects we have data on still. And so it just, I'm really proud of it. Walking it actually was quite stunning for me when it was done. When we had the opening party, I was just like, wow, okay. But and it just sort of kicked off a whole wave, right? But what we need to solve is ventilation still. So on our large scale projects, we really do as a team, we go to central systems. And I know there's a lot of argument over this, but the individual systems we see get installed are having problems getting balanced, are having problems getting their ductwork installation properly attached in a vapor tight way, are, you know, and are not performing, and they're loud. And anytime I go into an apartment that has an individual ERV, it's shut off when the occupants are already in there. So I feel that ventilation, but our constant volume large systems can't be boosted really, not yet, because the cost is prohibitive. And so that I think we need to solve. That would be my number one. Let's fix this. because I mean, it's so important today. I think we're doing a good job with the ventilation. I think it's running. I don't think with the large scale, I don't think it's getting covered up or, you know, taped off or anything like that. But it really would be good to be able to boost. If Mike Woolsey's on from SQAURE, he's going to be like, Lois, you can.
Can I just mean by boost? Sorry, I'm just going to fill in the blanks there. Lois, if you could just, sorry, elaborate a little bit. What do you mean to boost? I'm sorry, I might have missed that.
That's okay. So we're ventilating our large scale multifamily projects to the International Mechanical Code minimum flow rates that you can. So 25 in the kitchen and 20 in the bathroom. And that's even a little bit high, because when you look at a small apartment, that can be like 0.8 air changes per hour, right? So that's a lot of ventilation for one apartment. And it really hurts the energy budget. And so to run it consistently at a higher rate, like, so do you handle when they're cooking or when they're showering, would really make it very hard to meet passive house standards. If we could boost at those high use times, at those high moisture rate times or the high pollution times for just small periods of time, it would increase, I think, the air quality. And I think we're doing a good job with air quality now, but I think we could do better.
Thanks.
You're welcome.
I was going to bring Mike on from Seattle, but he's like, did I ask a question? And yes, Mike, you did. Is this site energy not source? Right at the beginning, like 2 minutes into Lois's. So maybe you might know what.
Oh, that was the office building.
Yeah.
Seemed kind of low at 148, but.
That's a source number.
That's source? Okay.
Yeah.
Jeez, I like those easy questions. Okay, Alana was next.
Hey, Lois, great to see you.
Hey, Alana.
Hi. I had two questions. I'll start with the office building. I was wondering, and maybe I misunderstood this, but when you had the higher density option, it looked like you had more heating than when the lower density, or maybe I misunderstood, but I just wanted to clarify that. Is that
no? The higher density reduced the heating demand.
Okay, good. So then I flipped the sides. Okay, that was my first question. Good, that makes sense. And then the other question was, given that Cornell, I think the program on Roosevelt Island, I think they had a buildings program or some program. I was just wondering if there's any research happening on the building, that is partnered with the university, whether it's, post-occupancy evaluations, for the occupants or any other type of monitoring given the context.
Yeah, no, the tech center is actually more like computer tech and that sort of stuff. We have been looking at the utility data since they ran it. And so we've been helping them troubleshoot. I think it can be lower than it is. It's low, but it could be lower than it is, just a little bit. That's about the extent of it, is us reviewing the utility data and working.
Yeah, it seems like a fantastic opportunity, with an institution like that to use it really as a laboratory in more ways.
Absolutely.
Yeah.
Thanks, Alana. David James, I think your question might have been answered, but ask it anyhow, because we may not have all been listening to the chat.
Okay, great. Good evening. I just had a quick question. I'm working on a New York City high school project that has a passive house storefront system. And we are a glazing manufacturer, Advanced Glazings. And the architect has specified the U value of the storefront system at 0.16. And we're having difficulty trying to figure out if that's 0.16 center of glass or 0.16 total system.
It's most likely total system because the passive house has a comfort criteria, and it depends on what your design heating temperature is. And in New York, the overall U value of that window has to be 0.167 or lower. So that's our comfort criteria. So that's what that's coming from. Now, I will say this, and I don't know, people don't like me to say this, but if you are putting the storefront in an area where there isn't going to be somebody sitting there for a long period of the day, if it's not where the students are sitting or standing while they're working or whatever it is, if it's in a transitional area like a lobby, you can waive that requirement and go with the lower U value.
Okay,
Okay,
makes sense. Thank you.
you're welcome.
Good one, David. And we had John from who's living in Thursday.
That's true, in the morning. Thanks, Lois. Great presentation. Drinking from a fire hose, but that was great. I had a very simple question, and we're way behind in large commercial projects here in Australia, and we're all trying very hard to see some come about. And it was really quite a simple question. Rather than saying, can my project be passive house, are there buildings that you've come across or thoughts you've had that are buildings that couldn't or shouldn't be passive house? It's probably a smaller group. So.
Yeah, you know, it's interesting. That's a good question. And there are projects where we've said this is not right for you. Honestly, some of the smaller projects we've worked on, like a really tiny house, like 1,200 square feet, we are like, this doesn't make any sense for you. We have to go to our 120 in the roof and our 60 in the walls, and it makes no sense. You're way past the curve on that one as far as where, you know, the cost effectiveness tapers off. So those projects we've actually discouraged. We've said, don't, you're chasing your tail right now. So, you know, you can get to net zero way before you have to go to passive house certification level. So that is one of the types. I'm trying to think, there was something else I told. It was a retrofit of some kind, and I was just like, you're just not going to get close, you know, like, I can't remember what it was, but that was it. But there's really only been a couple of occasions when we've said, this really isn't right for you.
What about factories?
Well, the Sri Lanka project is something different from that you're thinking about, like maybe a machine factory?
In machinery shops, and, you know, heavy duty stuff, I would imagine that the air filtration systems would be different.
Yeah,
so
you know, we analyzed like a mechanics garage, like for the city, you know, like where they bring all their trucks to be washed and serviced and stuff like that. And the air change rate in that place was like 10, so at all times. And so what we looked at was not passive house. We just looked at different energy efficient measures to help bring that energy use way down. And some of it was like preheating the ventilation air with solar, you know, so it's like techniques like that project. Why go for certification? Really, you just need to bring your EUI down. You know.
Thank you. We're all looking forward to the hospital in Frankfurt to see how that goes too. That'd be amazing to see how that works. And
yeah, me too.
Secondary infections, whether they're going to be down because of the cleaner air.
Yeah.
John, just a chuckle in the chat that you're missing out on is on my screen, I actually have you beside Mike, and you actually do look like each other. So there's a doppelganger in passive house. So
there's two good looking guys around.
There are, yeah. Two good looking rocking passive house dudes. Yeah. Rocking each coast. In the queue, sorry, I was enjoying the chat too much there. We have, sorry, John, we took care of Tom Balderston. You are up next, and then Beverly.
Oh, that wasn't really a question, just a reaction. I know it's a much more complicated issue. So
you put a question mark on it, so I thought it was a question as I'm trying to gather them all up.
It's a much bigger conversation.
Well, again, keep it when we will come back into the after hour. Beverly, you're up next. Thanks, Tom.
Sure. Lois, we're so excited. You're working on Winthrop Tower in Massachusetts, and I'm from Massachusetts, and I know I guess like a broader question, to broaden my question, incentives that you've seen in different areas, are they moving the needle at all? Like in Massachusetts, I think the multifamily incentive of $3,000 per unit through Mass Save seems to be attracting a lot of interest. And now there's that commercial, which I don't even know if it's eligible, if Winthrop is eligible for it. Do you see that being helpful? Is there NYSERDA programs like other states? Have you seen that actually move the needle, or is it just purely people who are interested?
No, it's totally moving the needle. So a good percentage, I would say 60-70% of our projects are multifamily, and NYSERDA offers a multifamily incentive. And the developers for affordable are incentivized because they hold the properties, right? They're paying the heating bills, they're paying for the utilities. So they're incentivized to use less energy. So if they can get consulting fees and some of the costs covered by incentives, they're definitely finding it more attractive. And Massachusetts is definitely one of those places, New York. And then the other incentive that we see in affordable is that the tax applications, the QAPs for the tax credit programs for affordable housing, if they get points for going to passive house, it's a no-brainer. People are trying to get those points all day long. So we've seen growth, like exponential growth in areas that put them on the QAPs.
But that's basically Pennsylvania with substantial points, right? I mean, Massachusetts now has 2, but Connecticut had 3, but now has pulled it. Vermont
Well,
has
they've pulled
1.
it, but they haven't signed it yet. We're like in an uproar over here. But there's a few, and like in New York, I think there's some applicability to it in the tax incentive program there too. So there's several states that are trying to do it. But you're right, it's if you offer extra points for passive house
Above
only.
LEED or green communities, right? Because the 16 states that have equivalency, no one goes for passive.
No one does it. Yeah.
Yeah.
Thanks, Beverly. Just to go back with Tom, I was trying to find out, because we've had this discussion in previous weeks on the happy hour, is what products does the SureLink factory make? And I'm going to try to find out so we could all support that awesome facility and maybe make some Passive House Accelerator t-shirts there, because that would be awesome.
That would be awesome.
Okay, keeping things going, Amir and then Rob.
Hello, I apologize for the crying toddler at the background.
Hey, we're all there, my friend. It's all good.
My question was about the laboratory building. If I was being approached to make an laboratory building passive house, I would have first thought, well, the air changes and everything else that happens in a laboratory would tell me that the envelope would have very little impact. And therefore, I was wondering what was the impact of the envelope on that very single project?
So how we evaluated the envelope was we took the ventilation rate down first, right? And so that we could actually understand, because otherwise, if you're at like 6 air changes per hour, you can't ever come near your heating demand. So you have to bring it to something that's rational, look at it, and also look how that impacts cooling with the high internal gains. So you want to find a sweet spot in those 2 numbers, right? And then you go forward and say to Passive House Institute, here's where the spot is, right? Like here's when we do our analysis, here's where heating goes up and cooling goes down. If we change it, we get this shift. And so we're right at the point where the systems are optimized. And that's sort of how it is, yeah.
So for the system optimization, when you start with the lower ventilation and then increase it slowly, I would think that it makes sense that the building alone would act passively. Let's say in a scenario where the ventilation wouldn't be as high, but for the hours that the ventilation is, let's say the 6 to 10 air changes that you mentioned, the envelope would almost be insignificant. Would you agree?
I would agree. It's not that way 24/7 though.
Yeah, okay, understood.
You know what I mean? Yeah.
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 Thank you.
You're welcome.
Thanks, Amir. Rob.
Hi, Lois. That's really great to hear about the stuff that you've been doing. And the question I always ask as a QA/QC verifier is for these larger projects, I've done some of them too, and I'm trying to replicate Stephen Winter Associates with a 3-person firm in Pittsburgh.
Nice.
But how do you find integrating more typical industry standard commissioning practices for systems with the commissioning that has to be done for Passive House?
So a lot of times we're doing something slightly different. Like if we're commissioning the envelope, right? The envelope commissioning tests are at much higher pressures and are kind of looking for some different things. We're like a lot of time the commissioning is for the window itself, not the window wall connection. And when we're commissioning, we're looking for the entire install. So we're looking for something slightly different. So sometimes there is no overlap. Now, when it comes to ventilation, our commissioning agents usually go around and spot check with the tab contractor. And so since we have to do that too, we have a nice overlap and we can reduce our services on one side or the other if we are the commissioning agent as well, just like the code commissioning agent. So sometimes there's some good overlap, sometimes there's none. When you're doing FIAS projects, there's really no commissioning agent on the, well, I don't want to say that. We have to commission the mechanical systems, right? We have to make sure the airflow through the heating and cooling system is at a certain percentage from the design, and there's no pressure differentials between the bedrooms and the hallway, that sort of stuff. I think that's a little above and beyond what our typical commissioning agent will do for individual systems like that. So I think sometimes we're more advanced, and then sometimes they're looking at something entirely different. Like they're looking at sequence of operations of controls and stuff like that we don't necessarily look at. So do you do both the normal code commissioning and then the passive house stuff?
I do envelope commissioning, and I work with other firms for the MEP stuff.
Mechanical, yeah.
Yeah. So that's just a topic that I'm pretty interested in, trying to make them work together. So
yeah. There can be some good overlap.
Yeah. Okay, thank you.
Good stuff, Rob. Wow, I guess with Lois talking so fast, this hour just kept on going, and we're pretty much done. So I'll come back in the after hour in a few moments. Zach, back to you.
Yeah, great. I'm gonna tease next week's happy hour, but before I do, I want to give a big thank you to our sponsors. So Passive House Accelerators work. So our website, the podcast. These happy hours are all made possible thanks to these great supporters of our work. So our founding sponsors are Baxt Inqui Architects, Mitsubishi Electric, RDH Building Science, SQAURE, and Zola Windows. And our stakeholder partner is NYSERDA. And our patron sponsors are Morrison Hershfield, 475 High Performance Building Supply, and Partel. So thank you all to our sponsors. And now I will switch to next week. So next week we have Todd Rothstein from the Avesta Housing. He's based in New England, and Avesta Housing does a whole bunch of affordable housing projects, including Passive House and other high performance building standards. He'll be presenting about that work, as well as a study that he's done comparing a whole bunch of affordable housing projects done to high performance building standards and their energy consumption. So it's, I know Monty co-presented with Todd recently. Todd did a fantastic job, and we're really excited to have him join us next week. So we'll see you there. Thanks.
All right, well, we're 3 minutes before the end of the hour, but shall we roll on into the after hour? Yeah, thank you so much, Lois, for that fire hose of information. It's fantastic. I'm sure that we have many more questions. And I don't know when we want to do our next breakout session or our quiz prize for that mystery device that was in the video, but
Thank you so much, Lois. It's always an honor and a privilege to see your work. It's so many brain cells going off at once, like so many others. So let's roll into the next bit. I'm sure there's another 20 questions and 20 more to come.